Given y plus 3/4 x equals 3, that's equation A, and 3x plus 4y equals 12, that's equation B, solve the system using substitution. Step 1, let's solve equation A for the variable y. We'll move the 3/4 x to the other side. We get y equals negative 3/4 times x plus 3. Step 2, let's substitute this result into equation B. So equation B is 3x plus 4 times blank equals 12. In place of blank, we replace the y with negative 3/4 x plus 3 from the previous step. Step 3, solve for x. Well, let's get rid of the parentheses by distributing multiplication by positive 4. And we're going to simplify each of our terms to get 3x minus 3x plus 12 equals 12. Combine like terms, we get 12 equals 12. We're lost. Where are we? Well, we're not lost, we're stuck. We lost our variables. There are no x's and no y's in 12 equals 12. We lost our variables, so we're stuck. Where are we stuck? We're stuck at 12 equals 12, which is a statement that is always true. We're just analyzing where we're at. So since 12 is equal to 12, an always true statement, we can draw the conclusion that our system of equations is, okay, what is it? Is it dependent? Is it independent? Well, when you are stuck at a statement that's always true, your system is dependent. It's a dependent system. And the solutions, remember how we write the solutions to a dependent system? Curly set bracket, all real values, ordered pairs x, y, such that, and then just write any one of the two given equations. I wrote 3x plus 4y equals 12. And then close my curly set bracket. That's the way you write it. But being dependent simply means that there are infinitely many solutions. Okay, so it's dependent because it has solutions. It's consistent because it has solutions, and it's dependent because it has infinitely many solutions. Now, how could we have identified this type of system without actually solving it like we did in the previous steps here? Well, we do this by getting both of our equations written in the y equals mx plus b forms, and then comparing the slopes and comparing the intercepts. So let's see, taking equation A and getting it into y equals mx plus b form, we start with y plus 3/4 x equals 3, and move the 3/4 x over by subtraction. We get y equals negative 3/4 x plus 3. That's y equals mx plus b form. The next equation was 3x plus 4y equals 12. So first, isolate the y term, 4y equals negative 3x plus 12. And then divide all the terms on both sides, all the terms separately, by the 4. We get y equals negative 3 over 4 times x plus 12 over 4, which is 3. Now that we have them both written in y equals mx plus b form, we see the slopes are equal to each other. They're both negative 3/4. So now we can compare the y-intercepts 0, b. For the first equation, we get 0, 3. For the second equation, we get 0, 3, which means they're also equal. The slopes are equal and the y-intercepts are equal. Now, if I graph that, you know what that would tell me? That would tell me that these are the same line. So they have infinitely many solutions in common. So M1 equals M2, same slopes, and B sub 1 equals B sub 2 indicates the same y-intercepts, and that implies that we have the same lines. And that implies that we have, of course, it's a consistent system because it has solutions, but it's a dependent system because they both represent the same line, which means they have the same solution. So I write my ordered pair, curly set bracket, x, y, such that, just list either of the two equations, 3x plus 4y equals 12. And that's just telling me there are infinitely many solutions. All the solutions to either one of those two equations represents all the solutions to the system.